What is the current Weissman score? I don't even know. I don't think we're going to make anything faster this stream because I only have an hour. What we are going to do is do a little bit more instrumentation on yields like we did that one time before the jackass stuff, but on a different part of the code, because that was on the polymorph part. And I want to do it on just the type inference part. And somebody on that stream had a suggestion of how to do it that seems pretty good, which is just to make a giant array like just put increment a number based on the line number. You'll see. You'll see. Okay. Anyway, this worked. So I'm just going to say small tweak to, or just comments. Okay. I'm going to get some water and then we'll do the thing. Okay. I'm going to go add another variable. We're going to say define profile yields. We're going to set that to 1. That's going to be a no check-in. I'm going to go to main. And we're going to do this. If profile yields, and if we're going to have num max yield line number profile yield count okay. Very stupid, especially because max yield line number is going to be big. So if you put file and line in here, will those be the file and line of the thing expanding the macro? I think it will, right? Right? Oh shoot, hold on. I forgot to set chat. We have now, chat is now appropriately set. In 2 years, I won't be 24 in 2 years. Dude, I turn 20 next year, okay? Come on. Is this a job for a meta program? This is C++ that we're doing this in, so no. No. Yeah. Okay, so we need to make these little data structures. Let me make the array. I'll put it next to the jackass things. So I'm going to say, oh, this should be under like if jackass, and if this should be under if profile yields, and if, and we're going to go int profile yield count max yield line number. Okay, so this has to go up here. We're going to go if profile yields and if. All right, so extern, and we're going to go, I guess I could do const. Okay. Now I just want to do vanilla yield here. So let me just, we're just going to make this a backslash macro now, because that's just what you have to do when you start adding things. And these are, of course, painful in C++ because you forget a backslash somewhere and it becomes a big disaster. Okay, so I'm just going to put this instrumentation right here. We're going to go, see, the reason this was all crammed on one line is so that it maps to the same line. Like, or no, wait. No, I guess it maps to the right line no matter what. We'll try it. We'll try it. Okay, so I'm going to say auto line equals min line max yield line number -1, right? And then profile yield count line ++. And then we need to do this only if, like, I don't even remember. Can you put an if inside a define and have that work? Probably not. That shouldn't go after the return anyway. Profile yield line. All right. So else, right, we go define profile yield line, right, line, what a mess. Okay, well, there's no min. Max yield line number, undeclared identifier. If profile yields, oh, cause fudge. Just going to put it here. Dude, this programming language sucks. We know that. That's why we had to make a different one. Are yields a synonym for gains? Yields are kind of like anti-gains. We want to make gains in yields by decreasing the yield of our yields. You know what I'm saying? Okay. Here we go. Look at all the yields, guys. Macro activations. Line 2714 is most, well, 5188 and 2714 have the same number. That's a little bit fishy. It's like maybe this one calls that one. We're going to have to look at that. 6552. So I want to look at these top scores here and just see, do any of these look more expensive than the other ones? Because there's yielding when you haven't really done any work, and there's yielding when maybe you threw away work, right? So we'll take a look. And the ones down here are like, oh no, because matching is different. Okay, let's just look. 2714. Okay, this is in a check that types match. Type check arguments helper. So we yield there a lot. So the one thing we're not measuring is if we re-yield on the same thing we already yielded. Like, do we yield more than once? Because that's the question. Like, because there's a sleep. This is like a polling yield, but we have a sleep yield. So what if we accounted two things? What if we accounted two things? Yeah. Okay. So do yield here. Where is that defined? It's got yielded on expression. What we could say is, we could do that. Okay. Let's get rid of this print. That's not good for anybody. Okay, so and we're going to go if redundant profile yield redundancy. Okay, so this is like if we ever yielded on the same thing twice in a row. I've got to, because this is such a crappy programming language, I've got to go back here and recompile the entire goddamn program. And then, all right, so now so we're going to say this, else we're going to assert that this is 0 because it had better be. All right. Okay. Wow. That was a useful experiment. I mean, maybe it doesn't quite mean what we think it means. But it sure looks like most of these only yield once, which is a little bit weird and surprising, honestly. I kind of don't know if I believe that. But line 5188, yields redundantly every time? What is, I'm not sure. I'm not sure that I understand the output of this. Let's look at 5188 though. This doesn't seem good to me. So we go, oh, this is just that type check one overload gave us a yield upon. Okay, so the deal is 27 type check one overload is going to call check that arguments match, which is going to call this, right? Or type check arguments helper. So the thing is, I don't know why this is not incrementing, but this one is, because it should be the same. Because we're yielding on star yield upon, and maybe whoever's calling this is changing the yield value. That would be weird. That would be weird. Okay, let's make even a third thing. The third thing I want to do and recompile the entire is potential sleeps, because there are certain kinds of things we could sleep on and certain that we can't. And the optimization for polling yield is to change it to a sleep yield, right? And I want to know, could we do that for all cases? Could we do it for many cases? What does that look like? So let's kick off that build. So sleep yield wants it to be another, yeah. We have to have a queued. All right. Okay, let's get rid of this argument then. Okay. Okay, we're going to say bool redundant equals queued yielded on expression is equal to E. Okay, but in addition to that, we're going to say if E arrow queued and queued not equal to E. I'm playing the parentheses. This is where C++ turns into Lisp. Profile yield potential sleeps line plus plus. I'm programming in a programming language called line plus plus. Can't double equal return false in case you're dealing with copies or some, what? Double equal returns false if things are not equal. Other than that, I don't understand the question. The point of double equal is to return true or false. Potential sleeps. Okay, so yeah, we just haven't created that variable yet. That's fine. All right. Okay. Okay. Almost all of these could sleep. All of these could sleep. Almost 100% of our yields could sleep, which is very good news. Now, the reason I implemented them as polling yields originally is because I was scared of bugs where you sleep things and then you don't wake up correctly, right? But so at the time that I did these, it was like, let's just make it work. But now, you know, we want to go fast. Got to go fast. Got to go fast, like Sanic ball. So I think we're going to try sleeping some things. I don't really know if this is going to affect. Let's just take some quick perf scores, right? And we'll see if they go up like at all, right? So we're going to turn this off because that'll affect our perf. Yeah, Twitch needs somebody to deliver the value to using line as an index is a cool idea. Yeah, somebody suggested that on a stream before when we didn't really need to do it for the thing that we were doing at that time. But for this, it's like we have a bunch of yields. Like you could see, there's that many in this file. And it's like, okay. Now, the thing that worries me, this second column, it's not right, and I don't understand why. It maybe doesn't matter, because we'll see if the number of yields actually goes down when we do the thing, but yeah, all right. So now, with the caveat that what we're doing right now is while streaming, so it's slower. We've got front-end time 0.64. So let's just say 0.765. We're going to take a few and just do a rough mental average. It doesn't matter because these measurements are so noisy. 773, 761, 781, we're getting slower. Oh my God. 766. I mean, let's call it like, yeah, let's call it like 775. That's a round number. I think the 79 was a big outlier. So if we're, I mean, again, if you're actually profiling this and you're doing like really micro things, you want to run like 1,000 times and get statistics on that, right? We're not doing that right now. What I just want to know is this a big enough improvement that you just see it in the profile, or is it not, right? Because if it's not that big, then it's like, well, okay, you know. So if we're 0.775 seconds, right? I'm looking at this number, right? And I'm rounding it up because we had some higher ones. We have 166,657 lines divided by 0.775. So we're at about 215,000 lines per second, which we've been a little faster in the past. I don't know why we're a little slower now, but one thing I want to do is just get rid of some of these yields because they seem wasteful. So, okay. Now let's go back to profiling yields and go back to debug build, and I'll turn one of these into a sleep yield and we'll see if we even run correctly. Right, okay, so going back to Sokoban with debug build. There we go. Boom, 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 same numbers that we were seeing. I mean, roughly. Like these probably change a little bit for each run because of threaded non-determinism in some way. Like, yeah, they're roughly the same, but they change by a very small amount, right? They change by about 40 or 50 on the scale of 17,000. So pretty close. All right. So let's just try making this one a sleep yield. Or maybe this one. It's weird. Okay. Oh, I know why this column doesn't make sense. Because when we re-poll an expression, we set yielded on expression to null. And the only reason that this one is happening this way is because it's redundant, because we call this and it sets the thing, which got set to null when we polled, right? And then it sets it here, and then it returns back up and sets it here, right? So let's just go. I'm going to make a comment right now. This is something where I'm going to want to think about the structure of this later. We don't sleep yield here since the caller in resolve potential overloads at the time of this comment, sleep yields from there, and it would be redundant question mark. We probably want to bulletproof this so that multiple subsequent sleep yields do nothing. Okay, anyway. Because like we pass the yield upon backup. Yeah. Anyway. So instead of saying yield, we have a sleep yield. It's got this weird name, sleep yield infer. If yield upon sleep yield infer on yield upon, I mean, we'll see what happens. How much of a disaster is this? So what I would expect is that this number goes way down and this number goes way down. How much is way down? I don't know. And maybe even this one. I don't know. Let's see. Or what I actually would expect is that we fail to compile because we don't wake up correctly. I don't know. Oh. Wow. Look at that reduction. Look at that. 271 from 17,000. Holy cow. That was a lot of redundant yielding. Okay. Line 5190. Oh, line 5190 has a sleep yield. So you don't even see it here anymore because it doesn't get profiled in this, but it's about the same. Yeah, okay, that's a pretty good Weissman score. Pretty good Weissman score. The sleeping yield save progress? No. Both of them have to save progress the same amount. There are some cases where you do redundant work maybe, but I try to minimize that. The difference is just that non-sleeping yield. Okay, So all these little compilation units, they get held in a queue, and the queue says like, okay, these are all the things that are waiting to get type inference run on them, right? And when it comes time to do type inference on some stuff, then either all the information it needs is ready, in which case you do the inference and then you take it out of that queue and you put it to the next stage of compilation, or all the information is not ready, in which case you have to stop what you're doing and come back later, right? So how do you come back later? Well, maybe you actually have a way of not trying this again until that information has arrived. Like maybe you do something when that information happens that then causes you to wake up on this thing and put it back in the queue. Or maybe you just leave it in the queue and repoll it every time you go through all the items, right? So vanilla yield is repolling it every time you go through all the items, which is a little bit of a relief because you don't have to worry about like, did this thing not wake up or whatever. But it's not good because you're redundantly checking this thing to see if it's ready yet, right? That's all. Now, what worries me a little bit about this accounting is that sleep yield doesn't actually always sleep. So I think we're going to want to do something there. Okay. So the deal is we call sleep yield which was where again? Ask.h, right? We call sleep yield. And it does this sometimes. What if I just do this? Return true if we actually no, you know what? We can just check. Okay. We're going to go if not current sleeping on profile yield line current E. All right. And I want to do that also for this version. Oops. Okay, so wait, what? Current is not a member of Lambda? Current is get current queued. If current is... What? Okay, this is, now we're getting C++. We're using macros, which is a fool's errand in C or C++, and you just get screwed by things. You just have to add 17 trillion parentheses sometimes. Now I have too many parentheses. Oh, because there's no E. Q expression. Okay, that wasn't... What did I do? Okay, let's... Current is not a member of Ast Lambda. Why? How are you getting E arrow? Where is that even coming from? This is what's horrible about this. What does this even have to do with anything I understand and can change? If not current arrow sleeping on, so current is not a parameter of the macro, so we don't need weird parentheses around that in any case. Sleep yield infer Q still has too many parentheses. I don't see why. So like that one goes there. Mismatch, okay. That goes there. Like this doesn't seem to have a problem. And the sleep yield with Q as a parameter never had a guys, I don't know what's going on with the macros here. Maybe I should break these out multi-line. Current is not a member. So lambda is E, but we don't do E arrow anything. Oh, but we do. Oh, maybe we pass these in the wrong order. Profile yield line, Q'd E. E arrow Q. It's got to be this. It's got to be this. So like E is E. But nobody says arrow current. Oh God, guys. This is a text substitution. Okay, this is very bad. Lol. 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 See, it's substituting this for the variable name, which was fine when it was called Q'd, which was what we passed. But yes, welcome to the land of non-hygienic macros, everybody. Missed one? I don't think so. Okay. So once again, our Weissman score has improved drastically here. It didn't really go up by much or at all, which is kind of what I was worried about that I would put in. Because this is saying, hey, if you didn't actually sleep, go profile that, right? And so the worry would have been that, hey, we didn't actually sleep, but it just skipped around the profiling, but we did actually sleep. And that's great. That's great. Let's look at 6555. It's collect overloads. All right. What if we do this? Wow. Wow, it's completely gone. I mean, GG's, that's about as good of a Weissman score as you could ever want. I mean, we can, no, not really. We can still drive these numbers down, but we just took 30,000 yields out of this list. And these numbers add up to like 7,000. Like we just eliminated 80% of the yields in the compiler. E arrow queued. The E arrow queued is the problem. That's supposed to be a different thing. How fast is it in release? I don't know. So we got rid of 80% of the yields. The question is, I don't know how much faster that will be in real time. It might not be any. We'll go measure it now. The thing is, those might have also been cheap yields, and maybe some of these other ones are more expensive. And then it would be important to hit these as well. Oh, let's make sure we pass the test. It's possible we've introduced problems that will cause compilation to fail. Yeah, these are just things where it's like, when I wrote the code, I was just like, I am erring on the side of not having problems right now because I was focused on making the compiler maximally robust and simple and understandable. And so I did a bunch of things that I knew were a little bit slow, and I was just like, I'm not going to think about it right now, right? Hey, look, it actually worked. Let's look at one or two more before we go profile again. Now, even if this doesn't change very much the amount of real time that we take, it does have the advantage that it'll help us when we go profile other things, like in telemetry or whatever, because the activity of the profiler will be, or of the compiler will be much less spammy with many fewer procedure calls and all that stuff, right? So you'll just be able to look at it more cleanly. So that by itself is even a benefit, even if there's not a clear numbers benefit yet. But let's see. So 7953. This is procedure call, but it's a different part. This is when there's a procedure and you know what it is, but like its type signature isn't ready. So let's try that one. So that's line 7953. It was 2811. It's completely gone. So it always sleeps. Dunzo, right? Let's try the tests again. The years of toil I have put into this compiler and making it fucking work better have been paying off. Because years ago, if I had tried to do the equivalent of this, it like wouldn't have worked. We'd have all sorts of compilation problems. Now it's like, look, we could do this and it just works. Do I think imposter syndrome exists? I think it exists, but it is a very, very rare psychological condition. And most of the people who claim to have imposter syndrome are just looking for excuses for why they feel bad at their job. Because they are bad at their job, though. You got rid of 0.2% of instructions today. That's major. That's a very different... That's major, though. Okay, so let's look at this one, because this is the other one that's above like 2000, right? So 1005, this one's in the type. No, it's not. Let's see. Resolve one ident. Okay, this is just an identifier binds to something that we don't know what it is. I don't know. Let's just try this. I don't know what that's going to do. All right, so that was line 10059 for 2308. It's gone. Dude, our Weissman score is so good now. Remember, we started with, we've eliminated now, you know, I could add these numbers up when we do this, but we've eliminated like 35,000 and we have, you know, 4,000 left. Something. It's banana nut balls. I almost can't believe that this worked that well. Okay, so now let's go back here and we're going to make a release build. We're going to see if the numbers budged at all. I think they probably, uh-oh. Oh, we need, okay. We need this. We can't just do that. Empty controlled statement found. Is this the intent? Yes, it is. Okay, so release build, let's go. 765, 750. We never got anything that low before. 754, 767. These are a lot lower actually. 760. 770, 770, 91. Okay, hold on. Am I running Discord or something? Let's exit Steam. Let's exit Adobe Land. Let's exit NVIDIA. Close assistant. What is that the assistant for? Anyway, let's call it 760. Okay. That's about what we're getting. We were at 775 before. So that's 15 milliseconds roughly. I mean, again, these are just back of the envelope, but that's 15 milliseconds, right? Before, our lines of code per second was like 213,000 or something, right? Now it's 166,657 divided by 0.760, 219. So we got 6,000 lines per second or something, which is like the entire compilation speed of Rust. Or of Swift or something. Swift. So it's not huge, but it's good. Like, we got to be pushing the numbers upward. Yes, we have made gains. Swift can't do 6,000 lines on a good day. Wow, it's really that bad? Well, don't worry, computers are just going to get faster. Do I think people will make popular libraries with monstrous metaprograms which will make compilation slow? Almost guaranteed. That's what people do. Just don't use those. Do I still feel like 1,000,000 lines per second is realistic? Of course, this is single core performance, guys. This is single fucking core performance. Mostly. I mean, again, we parse multi-core, but parsing is, you know, like most of this time is not parsing. And that's while we're streaming, right? As you guys know, I always say we run a little faster when we're not streaming. I don't know how, like, probably, I mean, we probably would get like 0.65 or below if we're not streaming. I could shut down the stream for a second and check. But what if it's 0.65? I don't know if that's accurate, but that's over 250, right? So, you know, when my computer is not being used to send bits to the people, we'll see if that actually, I'll take some more profiling numbers offline. But this is cool. This is like an extra. Let's go back and see if there's any other stuff. Because we could look at these other yields. Some of those other yields, even though there's not as many, they might be expensive yields. Does the compiler do some like force high priority thread stuff? I think we do. Like maybe we should give you an option. Yeah, so we set the priority class to high priority class. We could probably make that something that we give you the ability to tweak. Or maybe we just shouldn't, set this. I don't know. Feedback welcome on that issue. Oh, there's our old, we had a calculator running. That was our old thing, our 775 time. Okay, actually, it's not even a Swift amount of lines. So, right, if we said we went down to like 760, yeah, it's like 4,200 lines per second. Which again is not super a lot, but you just keep doing that. That's how you make things fast, is you just keep doing that over and over and over again. Okay. I mean, this was astonishingly easy for 15 milliseconds that we got. Let me just run the tests again. I'm pretty sure we ran this on everything, but I'll run them again. Okay, so, and then we'll run this. Okay, the only one over 1,000 is line 3167. Final. Let's try this. So we had line, uh-oh. One of our tests failed. Okay, this is the kind of thing I was actually worried about. So one of these, we haven't quite made these gains. we have to back out. Okay, so first of all, let's make sure this is reproducible. Okay, easy. Now, it's probably whatever the last one was that we did, which I don't remember. Good thing I ran those. But yeah, this is the kind of problem that I was expecting. Was it that one? No, no. I think it was this one. Wait, no, it was this one. 6536, I think. Wait, it was 6536, 6555. Okay, so we're going to just temporarily go yield on there and see if it fixes our problem. And I'm just going to fix the ones that are easy to fix. And then the ones that are hard, well, we don't really have time on this stream. No, that wasn't the one. Okay. I wonder if we're sleeping something multiple times. That could definitely be a thing. Okay, hold on. It wasn't that one. Maybe it was 7934. Dang it, 7954. Dang it. Okay, it wasn't that one. Oh, 10060, that's probably... Dude, I can't even edit in real time down here. All right. Yay, okay. So 10060 is our problem. I'm going to run through all the tests to make sure. So that one's painful, but that's fine. Let's go to, let's run the tests. And while we're running that, we're going to optimistically go here and do this one. Okay. Boom. Excellent. Okay, let me write down line yield on line 10060. That's one that we're dealing with. Okay. Well, it's 10061 now. I'll find, you know, it's that one. Okay. So that other 1000 yield is done. How's this? Boom. Excellent. Wonderful. Wonderful. This is all very good. This is all very good. I mean, let's make sure the game still runs, but I'm sure it does. Well, I'm not sure it does, but it probably does. And we're coming to the end of the time that I have for this stream. So I'm going to write down another thing I want to work on. Are there any like on-topic questions? Like we've gained a bunch of perf. I'm going to document it for the people. We have one thing to debug for that one other perf, but you know, reduce yields throughout the type checking phase, a total of 15 milliseconds saved there. So we saved basically, you know, 30 milliseconds this beta on the SOCO ban, which is like 5%. Anyway, so this one is still a problem. We're going to have to look into that. But really, I want to do a sweep through all these, right? And just get rid of all of them. Any questions, everybody? Before I sign off for now, this has been a very short stream, fitting between my call meetings of the day, and I just wanted to do something concrete, and it appears that we have done something concrete. We have added speeds. It's looking like a hefty beta. Yeah, I want to maybe ship it tonight or tomorrow. It's really, there's not a lot in terms of like big features, but just, you know, bug fixes, performance improvements, all that stuff. The assembly probably has the most in the way of feature. Okay. Let's get rid of this. And I'm just going to do a release build on everything, make sure that builds, and then I'll check it in. Is there a theoretical reason why stuff would have to yield instead of sleep yielding? You could only sleep on things that are separate compilation units, and I could imagine a time when you're pointing at something that is not sleepable in that way. Although that might then indicate that we should change that part of the design of the compiler, right? Because especially, so, okay, the thing to keep in mind here is yielding is also like very easy and non-serious right now because type checking is single threaded, right? When it's multi-threaded, then yield is really going to be more like I'm sleeping on asynchronous data, right? So if that data isn't really asynchronous or something, you could end up with a bad surprise, if you know what I'm saying. So that is definitely, probably it should be possible for all yields to be sleep yields. Otherwise, we don't really know what's happening. All right. Let's do that. Commit, change many yields in typer.cpp to sleeps to gain perf. Great. Oh, dang it. I accidentally clicked the wrong button. Good thing it saves it. All right. Thanks for coming by, everybody. We'll probably, oh, no, we have a no check-in, right? Because this one. That's fine, though. Hope that's the only one. No, it wasn't the only one, because I did a bunch. I did that one, too. This is the 10060. That's fine. We wrote a note about that one. All right, we are done. Fixes and performance improvements. Yeah. No, you can just say that. Like, look, oh, we totally improved the performance, guys. Don't worry about it. It's so much better now. Yeah. All right, thanks everyone. We'll stream again probably tonight. We'll probably do some more perf stuff like this because I think it would be great to go through almost all yields or maybe all yields in the compiler and take out the non-sleeps. We are going to have to debug that other one though. Thanks everybody. See you later on.